Hello everyone and welcome to yet another video. In the previous one we basically rendered or built a function to render flat terrain on the screen. So this is our world at the moment, and in this one we will start to implement some basic terrain generation. I think I'm going to begin by doing something related to midpoint displacement. So the idea of midpoint displacement is that you basically divide your terrain by half and then you move the midpoint either to up or down, basically randomly, and then you divide those segments in half again and you basically displace them recursively, right? I think I can, let me open a Chrome tab. Okay, so here in Chrome I can say something like midpoint displacement, and I can open a wiki page for it. It's also called the diamond square algorithm, because it has two steps, one the diamond step and another the square step. So this is the visualization. This is a 2D. We are going to use midpoint displacement on 1D, but the algorithm is the same. So you pick the midpoint, then you move it either up or down randomly, and then you need to move these points like on the edges, right? And then this is quite interesting. I don't want to implement it like this, I think. That's interesting. Okay, let me implement it the way I'm thinking about it, and then we can check the wiki afterwards if it is needed. Okay, so let me do something like a function. I can call it midpoint displacement, right? And then I can receive an x, basically, because this is going to be 1D, right? And this is going to generate me the y, right? So this is actually going to need the start of the segment and the end of the segment. And here what we are going to do is basically get the height. So here I need another array. I can call it heights like this, and this needs to be planet width inside, right? And it's going to be 0 initially. Actually, this could be the sea level, right? So we can have another macro, and here I can have a sea level, right? So 0 in our game is going to be the Kármán line, okay? And the Kármán line is, let me open it, is basically the line in at which the I want it in English. Can I search for wiki and see if this Kármán line? Okay, so this is basically the edge of space. So the 0 height in my game is going to be the Kármán line. So the sea level is going to be below the Kármán line. So it's going to be like an offset, a negative or a positive offset, because the height grows down, right? So it needs to be a positive offset. And for now I'm going to make the Kármán line, or actually the sea level, be, I don't know, so this is 256 blocks in height. We can make it 128 for now. So the sea level starts at 128. Cool. So everything, the heights of my planet can start at this, right? Because this is the sea level, right? So here we can actually already change this function, this init terrain function. We can comment this, because now we can base ourselves in here by just using, so this is the height, right? And this is heights at position x, and x height dot kind is grass, right? And then height plus 1 is going to be dirt, obviously, right? So here, if I compile and run, this should have exactly the same behavior like this. Oh, I must not forget. So 0. No, this is correct, I think. Yeah, I think it is. What was the previous behavior? So previously we had something like this, right? 128. So what was this showing? Okay, so this is different because this shows that there, and oh, because this probably doesn't, or does it? Let me think about it. So let's assume I have that. So because this probably doesn't initialize the entire array with this probably just initialize the first element of the array, right? So I have to manually come here and say something like size t, and basically I need to copy this, right? I need to copy this, and I need to initialize my heights thing, and here I don't have to use this, I just need to use x, and here I need to assign planet sea level, right? And this should now work as intended. Yeah, so because yeah, that only initializes the first element, and then the rest is arbitrary data that is in memory. Okay, so this is more or less what I wanted. So now we need to actually initialize this stuff. So I need to give it the start and end segments of the segment, right? And here I basically need to pick the middle point between start and end, and for that I can basically say that this is the mid, and middle, or I can say middle probably, and the middle is going to be ends minus start divided by 2, right? I think that's just it. So this is probably going to give me the middle. And I actually see, I probably want to make this recursive, right? And if I want to make this recursive, I need to check if the ends minus start is greater than 0. Like if it is less or equal to 0, then it is the end of it's the basic case of the recursion, right? So this is my midpoint, right? This is my midpoint, and here I actually want another parameter. I need something like a displacement, so delta height or something like that. And here I basically want to get a random number, and I'm going to use the function from Rayleigh between minus displacement of height, minus delta height and delta height, and this is going to give me the displacement, right? So I can call it age, right? I can call it age, and what I want to do is that to heights at the midpoint I want to add the displacement, right? I want to add the displacement, and this should do already something, right? Because now I can simply call this recursively, and I want to first make a call between start and middle, right? With I don't know, I'm going to pass half of the displacement for now, but this parameter can be tuned, right? And it's probably going to change depending on the planet we are generating, right? And here I want to start from the middle to the end. So if I have 10, 0, this will give me 5. So I probably want, well, does it matter? I don't think it does. One of these needs to be +1 or -1, I don't know. I'm just going to leave it like this for now, right? So let's try this one. let's see how it goes. The start is going to be 0 and the end is going to be planet width for now, and the displacement I need another parameter, so planet max mountain height, something like that, and I'm going to say 32 or something like that, right? Doesn't matter for now. Okay, so if I do this, I'm going to get nothing at all. That's cool, that's cool. Oh, because this is less or, yeah, less or equal to 0, right? It's not the opposite. Okay, this crashes. Why does this crash? So this is start and end, and this is start and end, and then we have this. Oh, this is yeah, okay. So if this is that thingy, or delta h is less or equal to 0, we don't want to continue, right? Probably. Okay, so this did something, I guess. Is not very satisfactory, to be honest. But okay, but it only worked on the left side of the map, right? It only worked on the left side of the map. And why is that? Because so this placed that midpoint, right? But then we go from middle to the end. It looks like this was never called, which is very strange. Let me think about it. So let me do something like a printf for now, where I print the start and end and the delta height, right? And delta height, and here I can try to see. Okay, so this is the start, end, and delta height. Cool, but okay, so this is already, yeah, this is working, I think. So something is not particularly good, because this should like modify the second part of the map, right? This is only modifying the beginning, which is already suspicious, right? It's already suspicious. So let me print start and height, then midpoint, and then the displacement of age, right? Okay, so this is the middle and this is age. What is this going to print me? So yeah, we should have, I mean, this is already, oh, but 128, 256. Oh yeah, obviously I'm calculating this wrong, right? Because this gives me the difference, okay, between basically this gives me the distance actually, right? If I'm not mistaken. So the distance is end minus start. So this is the distance between end and start. Then I want half of that, and to this half the distance I actually want to sum start, right? Because I want to use half of that distance from the start, I think. Yeah, I think this is the fix. Let me see. Yeah, that was the fix. Okay, so now the map is more or less generating stuff. Good. And I think this can be possibly improved. So I have end divided by 2 minus start divided by 2 plus start. So it's basically, so if I have 2 start divided by 2, then I have 3 starts divided by 2. Well, yeah, it's whatever. I probably can move this here. Start plus that. Okay, I can, I don't know if this can be more efficient, because one, mathematically this is equivalent to having n divided by 2 minus 3 times start divided by 2, but then this is another multiplication, and multiplications are not very, like, compared to sums, they're probably slower, I don't know, whatever. So we don't need this anymore. Okay, but this is the basically what it is called the diamond step, if I'm not mistaken, or it is the square step. I don't know which one comes first. But now we basically need, let's go back to Wikipedia. This doesn't really give me the algorithm, because I wanted to see in details, so whatever. So this is the diamond step, what you just performed, right? And the square step, what does the square step do? The square step, this is in 2D, I need to think about this in 1D, right? I need to think about this in 1D. What this does, this image is complete trash, it doesn't help at all. So we have this stuff in PHP, that's an option. Let's see what does this do in PHP. Go to source. I don't care about that, this is just boilerplate. So this is the square step. Okay, and what does the square step do? Oh, the square step basically... that's interesting. Oh, I see, then gets the average between that point and that point. Oh yeah, basically it's like interpolator, right? The square step is basically interpolates things. Yeah, I see, that's interesting. So basically what we need to do now is basically interpolate. But that's, I don't know why we need such fancy names like square step and diamond step and stuff like that, but the square step is basically interpolation between this point and that point, basically. Okay, so okay, we can try to implement that. So this is our diamond step, you can call it diamond step, and then we need the square step. And does the diamond step come after, or can we, or is it irrelevant? I think about, can I run the diamond step on all points and then the square step, or do I need to run the diamond step and then square step and then diamond step and square step? Like, I think you understood that. So let me think about that. I don't know, that's actually quite an interesting question, right? Well, let's think about this. So when do I need to interpolate? Let's start with smart, right? I only need to interpolate, so between these, but I probably want to have layers of interpolation. I need to interpolate always, right? I probably always need to interpolate, yeah. So let me have another function. We can call this square step, and what I need to do is to basically interpolate between start and end, if I'm not mistaken, right? And what we need to do is get the start height, and the this is actually start. Oh, but no, we need the middle, right? Because I need to interpolate. Yeah, we also need the middle, so we can calculate the middle here as well. And this is the ends, right? I think so. I'm a bit confused, to be honest. So this gets To begin with, what is this x and y? Oh, I see. So they first apply the square step and then they run diamond step. That's it. They are basically doing the reverse of what I'm doing. What I was doing, it works, but it doesn't make much sense in my head, and this actually makes more sense because they basically interpolate before the diamond step and only then they recurse the diamond step. That actually makes more sense, to be honest. That actually makes a lot more sense. Huh. That's interesting. That's very interesting. And where do they call the square step? Here. So they call the square step. Oh, that's strange. I don't like this implementation because they traverse every single one of the points. I don't. Well, it is. I also traverse it, right? I have a base case that probably. Yeah. Well, but my base case is a bit more efficient because in my base case I check if the height, the displacement height, is 0. I want to have another take a look at another implementation. So diamond square algorithm, yeah. So we have something here explained. I don't know which one of the implementation I like the most, to be honest. So this one does the same thing. I don't know why well, I can have probably an if statement, or can I? So let me take. This is the diamond square. Okay. This applies the square step, and then they apply the diamond step. Okay, so they always apply the square steps first. So they interpolate first. I'm assuming that the square step is interpolation, right? And here what they do. Okay. So basically they get, yeah, they get the average. Why do they, oh boy. Okay. I want a simpler example, 1D, right? I want it in 1D. Right? So they have this idea of step size, but their step size, so their step is basically my delta height, right? I think that's it. I believe it is. Maybe. Yeah, I think it is. So they loop, yeah, they loop while the step is greater than 1, that makes sense. But you see here, they do the diamond step first, right? So you can do them, it is not necessary to do them like one before the other. You can basically interchange them, and this is my initial idea, so I think I am going to take a look at it. So here, for each square in A, okay, and what is the diamond square? Okay, average of square corners, step size apart. I see. This is still 2D probably, but, and these are the four corners of the diamond. I think that Wikipedia confused me. I think that the implementation in 1D is a bit different. It is probably a bit different. Okay, so what I want to do, let me do what I wanted to do initially, right? So let me just call this step, okay, whatever. And here, this is my midpoint, right? This is my midpoint. And what I want to do, is basically have this separate, right? Yeah, this is my delta. This is my delta, and if my delta, oh, but I need to okay, but let me test my idea. So if my delta is less or equal to 0, I want to grab my start and end heights. This is not going to work, but it's going to give me a general idea of what I want to do. And I want to average of that, right? So I want to sum them up, then divide by 2. And here I want to say that my height, my height at this particular point, so I can move this up. Oh, actually, just to be a bit more efficient, I can move this here. You can see that the height of my midpoint is going to be the average of the begin and end of the segment. Let me see what this generates. It doesn't generate anything. That's interesting. Why is that? Oh, because here I need to do that, right? I think so. It still doesn't generate anything. So and if I do that, oh, because I need to return afterwards, right? I need to return afterwards. Okay, so this did something already a little bit different, but this is not exactly what we want, right? This is not exactly what we want. And do I want a weighted average? So the distance between the start, oh, but we are here always doing the midpoint, right? Yeah. Man, I wish I didn't look at Wikipedia. Oh my god. Let me midpoint displacement when we hit up. Let me see if there is. Okay. Yeah, that's probably what I want. Where is? Oh my god. This doesn't link the implementation. Okay. Take an array and set random values at the first and last value. We are okay. Take the average of those two values and set it to the middle of the array. And this is what Wikipedia calls a square step, right? Pass first and middle value to the function. Pass middle and last value to a function. If first plus last divided by 2 is less or equal to 1, return. We are doing that. Take a new middle point between first and last. Cool. Set displacement to the new middle point from average from the last two values. Okay, but so the float that determines the roughness of the curve range from 0 to 0.9. Okay, R is a okay, but this they are using the fancy stuff because basically the real midpoint, the author suggests to, instead of like dividing the delta by 2 every step, it suggests to use like e to the power of negative or something like that, or square root of r or something like that, but doesn't matter, right? So I think it okay, so they suggest to use 1 instead of 0 here, right? So this is what they suggest. First plus last divided by 2. Why is that? So, oh, I see. If the distance, yeah, that makes sense. So, okay. So I can do something like, let me think. So this is the distance, right? And this is end. No, wait. Why did first plus last divided by 2? That's not correct, right? Oh, I see. So the first, well, but this is not going to work. if I have 10 divided by 2 is 5. Yeah, this is not, this condition I don't think is correct. I think what they wanted, maybe, or at least what I have in my mind, is the distance between the end and the start, right? And that's end minus start, and if the distance is less or equal to 1, we can return. Cool. And here I can just use distance divided by 2 and sum that to the start. Okay. Then okay, so they basically, instead of running the random value here, what they do is that they basically say that the midpoint height is going to be equal to this, right? Yeah, basically to the average of the start and the end of the segments, right? To the start and the end of the segments. I probably want to keep this condition, this delta less or equal, for now. Right, I want to keep that for now. This is my midpoint, I don't need this anymore. So this is my midpoint and this is my new mid height, right? Okay. So now my random value needs to be not here, but actually I no longer need to initialize the entire array. In theory, I can simply do something like this. So 0 is equal to that, right? And I can say that my delta is equal to this, right? I can say that my delta is equal to that. And here I can, for now, pass delta divided by 2, right? Delta divided by 2. Let me see what this generates, I guess. Yeah, let me see. Okay, so this really gave me something interesting. Oh, because, yeah, I see. Because this is probably triggering a lot of times, right? This is probably triggering a lot of times. So, let me think. But I'm not using delta anywhere here. That's what is the most confusing stuff. Let me close down this window. That is very strange explanation of what it is doing. So terrain.c, I suppose it's here. Cool, this is not what I want. Where is the implementation? Is it in main? Right, so I don't think, if at least from the what it's written in the readme, I don't think this is correct algorithm, that one. Yeah, I would suppose it would work something like that, right? Let me take a look at it. So this is some language. I suppose it's somewhere here. Right. Okay, so this is probably, yeah, this is a class, okay. So we have start and end, and this is the center. Oh, this is what they do. So this plus this, okay. So this is actually a simplification of what I was complaining previously, of not knowing what was the correct expression, right? So if I sum these two and divide by 2, this is going to give me the midpoint, right? Okay, cool. So now, okay, that makes sense, right? So that makes sense. So this is what I had previously. I can say that this is my delta, I don't know, what do we call it here? Offset, I don't like the offset name. I can call it h, whatever. And this is, once again, get random value. Cool. And the minimum is going to be minus delta. And the maximum is going to be delta. Okay. Then this is basically doing exactly what I had previously. So heights at mid plus equal h, nothing special, nothing special. Here, I don't know what this is, keep normal. Oh my god, so this is another Haskell lover. Okay, so I'm going to just do suppose. Okay, so this just applies a new line. Okay. With point, new center point 2. Okay. I just don't get it, why they... Okay, whatever. So here, they have a bunch of lines because they draw the lines, right? When they generate, they specify the iterations, okay. And what they do, they basically just displace and they divide the offset by 2, right? Okay, but they don't really have a base case. They don't really have a base case. That's interesting. That's actually very interesting. Let me check something. So if I bring back my previous code of doing this, right, and I then just call that with that, for example. Yeah, so what is this? Is probably going to crash, right? Oh no, because I'm not recursively calling it. Okay, so what they are telling me is that they, instead of having the function recurse, they basically just have another for loop, right? They just have another for loop where they basically, yeah, but let's let me think about it. Yeah, it doesn't really matter, I can just recurse. So start is going to be start, is going to be mid, and delta we can divide by 2. Same thing here, mid and delta, and here I don't want to do that. Well, yeah, I need actually I actually want to have something like end minus start less or equal to 0, for example. Okay, and this crashes, right, because this. Okay, but this basically gives us the same problem. What I'm not really able to get is that we need to have interpolation between this and this, right? Right. So let me think. There's one thing I can do is that whenever I do that, right, so I basically check for that. Okay, cool. I have my mid, my height, and I set my new height. And before I recurse, I can loop through so from start to mid, right? And now I probably want a weighted interpolation. Well, it's not a weighted interpolation, but rather like a weighted average or something like that. And so I basically want the distance between this x and the start, right? So the distance to the start is going to be equal to x minus start, right? Then I want the distance to the end, or basically this midpoint, I can call it mid, and it's going to be equal to mid minus x, right? And I want the distance between the start and the mid right? I want something like this. Distance between start and mid. Okay, so I have the distance from start to mid, and now I basically need to weight of each segment, right? The proportion. So what I can do is to get this. I need to convert it to a float, right? I need to convert it to a float divided by that, and this is going to give me the weight, and I need to multiply that times this, right? Let me just convert it to float just to be sure, and this is going to be give me the weighted height start, right? It's going to give me the weighted start height, and this is the mid thingy, and for this I need to use the mid, and I need to use distance to mid, right? Cool. And then, oh, what am I doing? And then I just need to set the heights of x to be equal to the weighted height of the start plus this, because it's already weighted, right? So it's probably properly interpolated. So I have unused variable start mid, because yeah, this is actually that. Okay, so that's already something, right? This is like this because I need to do the same for the end, right? From mid to end. But now this gives me an idea, right? Since I'm doing this after, nothing prevents me from doing it before, right? Nothing prevents me from doing it before. And if I'm doing it before, I do this kind of stuff. And this is probably what Wikipedia calls the square step, right? I can go from start to end. This can be my segment distance, segment, the T missing, and this doesn't need to be inside the loop, right? So this is basically end, oh my god, end minus start. So distance to start, that's correct. Distance to end, right? This is to end, and this is end minus x. And I probably want this to be float already, because I'm going to work with them as floats, right? And now I just need to convert this. So, and this is, what did I type here? Okay, weighted start, and this is weighted end, right? Weighted start and end. This is end, distance to start, and this is distance to end, and this is segment distance, right? And then I just sum both of them, and this is my interpolated height. I think that's correct. I think so. And if start, this is already not going to do anything, because yeah, so I don't need a base case before that. Okay, so let me try this. What am I getting? Whoa, this is definitely what I didn't expect this. That's strange. That's strange. Oh, because this is, yeah. I see. I see. I think I see it. Because so if everything starts at this point, then that interpolation shouldn't affect it, right? Boy, let me something like this. Let me do something like this. I can do something like that. There's some bug somewhere, I don't really know. Where is it? So I'm getting negative heights somehow, which is not very good. So this is a distance. This should be the weighted stuff, right? I don't need this anymore, to be honest. This one and this one. Oh, because yeah, this one needs to be calculated first, and this is probably multiplying it. Yeah, okay. So this needs to be calculated first. This is one of the problems. Okay, cool. So, but this is still giving me very small numbers. What am I printing? Heights? Oh, because 0, yeah, so 0 is the stuff. Yeah, okay. So this actually needs to be sea level. Another problem, right? Okay, so this is still giving me negative numbers somehow. This is still giving me negative numbers. So this is the first run through the segment. This is the second one. This is the second one. I don't know why it is setting it to 0 if heights. So let me actually print something like this. So this is my heights at x. This is my start. And this is my end. And I should basically just interpolate between them, like depending on the distance of that point to the to each one of them, right? And but somehow this is not really working as I expected it to work. Okay, it's printing a lot of stuff. Okay, so it kind of converges into negative numbers somehow. Why is heights start here always 0 when I clearly like initialize them with things in it? What? That is very strange, right? Because I have heights here, cool. Then I set them to be planet sea level, and that is 128, and this should print stuff correctly, right? I expect it to be like 128 at the beginning, but it is not for some reason. So if I do something like this, what do I get? I made a bug, I made a mistake somewhere, I just don't know where exactly I made that mistake. So let me see. Okay. So this is properly initialized, right? 128. I just have no idea why this is returning me 0 when I enter the function. Right, there is nothing special in here, I think. So this is start, this is end. Let me, I don't know, print something like this. Maybe this is going to help. This is x, heights. Oh, this is actually the other way around. So you have x, heights, x, and start, heights, and end, heights, end. So this is correct, right? It is correct. Okay. And this is giving me negative numbers already, which is wonderful. Okay. Yeah, that's the problem. I don't get it. Why this is giving me stuff like that, to be honest. Because we already saw that this is properly initialized before we step into this function. So if I do something like that, if I do something like this, what am I going to get? Yeah, I can print that. What am I going to get if I add something like that? There's something very weird in my code, that's for sure. I need to... okay. This is all okay. So... and height is 0. Oh, I see. But why is this looping through? Oh, I see what's the bug. Because planet width needs to be -1, right? Because this is the width and I want the index. And that is probably the bug from the very beginning, I suppose. Let's see. Because this is accessing elements outside of the array, and yeah, that was the bug. Welcome to C, everyone, welcome to C. Okay. And this is generating me some terrain. Okay, some terrain. Cool. And I suppose this is already properly interpolated. Because if I don't have this, no, I can actually check it. If I don't have this, let me see. Yeah, so this is the map generated without the interpolator. And if I interpolate data between segments, I get that, which is not perfect, right? It's not perfect. And I'm, because this should be interpolated, but it's not interpolating it, right? It's not really interpolating here. Let me think about it. So I start and end. Should I maybe do that? Should I do that? That's a great question. I probably don't want to do that. I probably don't want to do that. Or do I? So here, I'm going to, if I have something like this, I'm going to interpolate between start and the midpoint. But the midpoint is then going to be changed. So I actually want mid plus 1, right? Maybe. Okay. That's not really what I want. Or is it? Actually, what I don't want to do is to change the start as well. So probably I want start plus 1 here. Yes, okay, that's already something good. Cool. So this is looking more like mountains now. So let me explain what was the issue. I probably want paint. Okay, let me draw something on paint. So we are basically doing our midpoint displacement based on segments, right? Ignore what Wikipedia says. That's, for me, that just makes me more that just makes the algorithm more complicated than it needs to be. I prefer to derive it myself, right? Otherwise I'm going to get very confused. So let's imagine we have a segment, right? And what I'm doing is that at the beginning of my midpoint displacement step, I get the height of the beginning of the segment, I get the height at the end of the segment, right? And for every single point between these two points, start and end, I'm going to calculate the distance. Let's assume like I'm at this point, right? I'm going to do this for every single point, but let's just take a concrete example. So I'm at this point. I take the distance between these 2 points. I take the distance between these 2 points. Let's assume that height at the beginning is this one, right? And let's assume the height at the end is like below the sea level, like lower. And I'll calculate the weighted average between this height and this height based on the distance of this point to the start and the distance of this point to the end, right? So this is going to have a lower influence than this one because this point is closer to the beginning, right? So this point height, the weighted average is going to be something like this, right? It's going to be above sea level. It's going to have more influence, right? And I'm going to do that for every single point in this segment. So I'm going to do that for here, and then this is going to probably like do something like this. And this is going to be a straight line because I'm not using any fancy interpolator. I could use a fancier interpolator in the future, and this is probably going to, depending on what interpolator I use, I can actually put a comment. It is a good idea, right? Depending on the interpolator I use, I can generate different kinds of terrain. That's a very good idea, right? Because depending on interpolators, if like I use a sine wave or something like that, then this is going to be more curvy, you know, and it's not going to be like that straight line. Currently we have this straight line, right? Okay, so this is my first step, right? And this is what I think, I'm still not sure, but this is what I think Wikipedia calls the square step, right? I think this is what Wikipedia calls a square step. Then we go to here, this was the square step. But then we have this code, right? And in this code, what I'm doing is that, well, I have these segments, right? I have the same segment, so this segment begins and ends here. And now I have my height map that has something like this. right? So this is my height map, and this is the segment. This is my x0, and this is my xn, right? And this is my y0, so this is my y0 and this is my yn. I know this is not mathematically correct, but you understand the diagram that I'm writing, okay? And what I do here in my second part of algorithm, I basically get the midpoint. So this is x0 and this is xn. I get the midpoint of the algorithm, of the segment. Let's assume that the midpoint is here, right? So this is my midpoint, right? And I don't traverse all points. I just go to the very middle, and I don't do anything to any other point in this step. So I get my midpoint, and basically I just get a random value. Let's say get rand, right? And I get this random value given a delta, right? And this delta is going to be this random value is going to be between minus delta or delta, because we, as you can see previously, we can either move up or down, right? So we can do between minus delta and delta, right? That's completely valid. So we get this, where is my mouse? It's here. So we get this random value, and let's say this is age, right? And now this is the height of the midpoint, right? So this is y mid. So this is the height of the midpoint. And the only thing I do is that I either increment or decrement this height based on age, because age can be negative or positive, right? Because we are getting a random value between minus delta or delta. So this midpoint is going to move either up or down, right? Let's assume it moves down. So this is the new height of new y mid, right? Let's assume it moves down. And we are actually like accumulating these random values. We are not like setting it, right? We are just summing. So whatever we had in previously, right, we are just adding the displacement, right? And then we do recurse, right? And then we split our big segment into two smaller segments. So this is going to be my other segment, right? And we do that. So here we are going to have this function, and here at the midpoint we now have a new value of the midpoint, which is going to be here, right? And this is not a point, so this, right, this is the point, the new calculated point, and then we continue our line, right? And then we go back to the beginning, right? We apply the square step again, and this is my diamond step, right? And we apply the same thing again, and this is basically interpolation. Like the square step, I think, okay, from what I was able to think and derive, is nothing but interpolating between the endpoint of the segment. So this is my first segment, and this is my second segment. So this is my first segment, so we have to interpolate between this point and that point, right? And here, oh, but this is interesting. I'm currently like setting, well, yeah, it makes sense to set it. And this is my second segment, right? So you have to interpolate between this and this. And we do the same thing. It's a weighted thingy. So it's basically going to interpolate based on the distance of each individual point to each end of the segment. So here we are going to basically generate this new curve, right? Also a straight line, because we are using just a very simple interpolator. We could use something fancier in the future. And here we interpolate once again and generate this one, right? So now in one square step, in two square steps and one diamond step, we were able to go from, let me zoom out, okay, can I do this? Okay, so we were able to go from this, so basically from this line, right, or this height map, into this height map, which is basically something like this, right? And this is how this algorithm works. Basically it adds terrain features with based on some randomness, but since we are accumulating this randomness based on the previous terrain roughness, let's say like that, we can accumulate it and we can generate more or less like good good mountains and stuff like that, right? So we were able to generate, and this is like already has some good shape, you know. It's not like a complete mess, I think. So one thing that I would like to do as well is to prevent these kind of situations where we have, like, you see this very like rough patches and stuff like that. I don't want that, right? I don't want that. So what I probably want to introduce is a maximum segment size. The notion of a maximum segment size, I think. Oh, sorry. Let me say something like int maximum size, right? And if for some reason, so this needs to be done afterwards, right? Yeah. So here I basically want to do, let me call this segment size, right? So if my segment size is, this is actually minimum, sorry. So this is a minimum segment size. If my segment size is less or equal to my minimum segment size, I don't want to continue adding like features to the terrain, right? So if I say something like the minimum segment size is 16, let's say, what's going to happen here? Oh, I forgot to add. So this is my minimum segment size, right? What's going to happen here? Right, so this doesn't really do what I wanted. Because this still needs to even though we have a minimum segment size, this still needs to interpolate, right? That still needs to interpolate. And why is that? Is it because I have this one here? I doubt it. Let me see. No, yeah, that clearly was correct. But that's very strange. Is because so if my segment size is 1, what do I get? I get this, right? I get that. So I think that this extra roughness is probably because I have some bug, I would say. Right? I have some bug. Because I also need to take into account the previous segment, right? So we need this +1 here because we don't want to change whenever, like in this step, whenever we interpolate, we don't want to change this point or this point, right? We want to keep this point. We just want to change this line, right? That's why we need that +1. But by incrementing the segments, the minimum segment size, I am getting this, which indicates to me, which implies to me that so this is that, and I assume the segment size ends here, right? Because we have 1, 2, 3, 4, 5, 6, 7. Yeah, that's probably 32 blocks. So this stuff, why is it interpolating it like that? Why is it interpolating like that? Let me think. So this is my delta, and I'm using that. So I'm dividing by 2, so I know that this works in powers of 2. So let's say I just want two things applied to it, right? Yeah, two steps applied to it. So if I do this, okay, that's not going to give me too much stuff. Let me keep this at 32 and let me add this like an n for now. This is just for debug. That's just for debug. And I can say if n is greater or equal to 4. Don't turn anything. So I just want this to run 4 times. And this needs to be n plus 1. Right, and here I can probably use 1. Too many arguments. What are you talking about? So I have start and delta. I have no idea what you're talking about. Let me try to compile this. Yeah, it compiles whatever. So yeah, and if I run it just once, no, yeah, if I run it just once, that means I need to put it like that. What am I going to get it? Okay, so this stuff is not properly interpolating, right? Because I would expect this to be 2 lines, right? I would expect that to be 2 lines, and why isn't it working? So that is very interesting. This is my weighted start. Oh, I see, because I'm calculating this wrong. Because this weighted start and this weighted end, the sum is always going to be the well, is it? I think it is. I'm not calculating this properly. Let me printf. I probably need lerp, not this stuff. Why am I doing this? Well, I don't know why I did this. I actually want lerp, not that. Yeah, I want lerp. Let me just print this just to make sure that my reasoning is correct. So yeah, this is always going to be what? Why did I do this? I don't understand why I did this. Okay, so what I want is lerp. Do I have lerp? I think that Raymath has lerp. Let me see. Lerp, yeah. I'm just going to copy. I don't want to import an entire lib just for a function. So let me just do this. Cool. So, okay, so this is my start. This is the amount end. Okay. Cool. So if I do, I can call it lerp f, right? So what I actually want is to say that height at this position is equal, right? So the start is going to be oh, that's interesting. That's interesting. Do I want lerp? Basically, what is the amount? Amount is probably, yeah. So I can measure it by the distance. The distance to the start. So if I say that this is the start, so this is the height of the start, then I pass the height of the end, and then I pass the relative, like in floats, right? The distance to the start, and I don't use any of this, right? I don't use any of these, and I just print. Well, I don't need print because I'm going to view it on the screen. So what is this going to give me? I don't know. Yeah, I no longer need this, and this needs to be, yeah, semicolon. So this doesn't give me anything. This doesn't give me anything. Why is that? So this is on 127, right? And then this is the distance. Why am I having so much trouble doing a simple interpolation function? Like, I don't understand it, to be honest. So this is not what I want. Let me see what these guys used. Oh, this one I already seen previously. This is in Python. Wait a minute. Here, let me open a new one. So if I have a segment, right? Do I even need to traverse through all of this? Do I need to traverse through all of this? Because I can probably just get the mid one, right? Because the recursion already traverses to all of them. That's actually an interesting point. I actually don't need this for loop. I actually just need to say that the heights right. So I can say that height of these I can move this upwards is equal to the average of these two. Right? And I don't need this stuff. I think. What is this going to look like? Let me see. I already have too much stuff open. Okay, so this is okay. So this, yeah, it's very low. Okay, but then if I add another thing like 4, then I'm going to see. Okay, so this went off the map. It went off the map. That's probably because I have this too high. Let me say 16. Because this is not the maximum mountain height, this is actually the displacement delta, right? So it's accumulating stuff. That's why it gets so, yeah. Okay, but this is basically, yeah. So we have that, and then that. So if I add, let me say something like 8 actually. Yeah, let me say 8 to see if this is more reasonable to look at. It still generates the same stuff. It is very strange why it generates the same stuff. Okay, if I do something like I want 5 steps, so this is the next one. This is generate, yeah, whatever. Okay, so this basically generates me this terrain. What if I want, let me remove lerp. What if I want like 10? What does it give me? Oh, I think oh no, this is correct. Oh yeah, no it's not. I need to do that. Okay, yeah, that was why it was weird. Okay, Okay, so this now is generating me some mountain, right? So this is the stuff, it goes up and then down. Okay, cool. Let me do something like 100. Okay. It gave me this, but why didn't it? Is it because of this minimum segment size? But this shouldn't. Oh, I see, I see. Okay, I see. So we need actually two recursions, right? When the segment size is less than a minimum, or delta is less or equal to 0, and in this case we still want to recurse, right? We still want to recurse, but since we want to recurse always since we want to recurse always at the end, we can just say here is greater and is greater, and we can just move this upwards, right? We can just move this upwards, and this is probably already going to do something, or crash. That's also another option. Oh yeah, because I still need a base case, right? I still need a base case, and my base case for my recursion is actually going to be this, right? So if my segment size is 0 or less, I don't do that. Okay, so this is now looking better. This is now looking better. So if I change my segments, minimum segment size to be the size of the planet, what do I get? I don't get anything interesting. Oh, that's interesting. Why is that? Why is that? Well, let me remove that stuff. I no longer need it. Okay. Okay, it now crashes. So I actually probably want this to be up here, to be honest, right? Okay. Let me not have this for now. So let me not use minimum segment size for now. Well, this is crashing because I'm probably doing something wrong, right? Let me actually say 60. This still crashes. It's very weird. Right? It's very weird. That is definitely very weird. Okay, here I just interpolate it. Here I get a random value. Well, I don't even need to set this into a variable. I can just say cat, right? I don't get it why this is crashing, to be honest. Let me add printfs here. Let's see. Oh, sorry. Let me not do that, and actually this is probably in an infinite loop somehow. Okay, this this is always okay. I see. Is this a 1 you want me to put there? Oh, did it? Oh, I just crashed my... Yeah, I just crashed my console. So, let me take a look at it once again. Okay, it wanted a 1 there. She's weird. She's definitely weird because segments, they always move. I guess so. It's... yeah, I guess so. Whatever. So, yeah. So it's never 0. The segment side never gets to 0. Oh yeah, it makes sense because... yeah, actually, it's probably... the minimum is probably 3. The minimum is probably 3. But let's keep it like this for now. So if I don't apply this condition, what am I going to... actually, we can actually say something like 256 or something. So this is the most weird thing, because the larger I set this value to, the less features I have. Let me increment this, the displacement, because I want, yeah, larger stuff. So that's something. And if I set the minimum segment size to this, what do I get? I get larger stuff. Oh yeah, because the minimum, yeah, this is the minimum, not the maximum, the minimum segment size, right? That makes sense. So if I set the minimum segment size to 1, then I should get like really fancy stuff. Yeah, this looks much better. Okay, so this looks much better than we had previously, right? Because if you remember, previously we had like very jiggly line, and now it's a lot smoother. It still looks like mountains, you don't get me wrong, but it looks much better. You know, it's starting to look very nice. You know, you can now imagine a character in here and like a player moving around, and it looks good. I like this algorithm, to be honest. I really like this algorithm. I probably don't want, I mean, well, I probably want it because multiple biomes or different types of biomes may have different requirements. So because the larger the minimum segment size, like the flatter the terrain is going to be, I think. Yeah, as you can see, like if I have very large thingies, my terrain gets, or at least it gets less rough, you know, less rough. So if I add this, you know, it's less and less rough. So this like controls the roughness of the terrain, not really the flatness, is more roughness. So I can say roughness. This is more like a roughness thing, and not really, yeah. This is more of a roughness that we can control. And the other thing I would like to check is this delta. I know that there are better things. I don't remember what... this is it. So each value is multiplied by a scale constant, which decreases with each iteration by a factor of 2 to the power of negative h. Right? Where h is a value between 0 and 1. Lower values produce rougher terrain. Okay. So what factor do we want to use? Right? That's the question. What factor do we want to use? Let me think. So I'm going to need a float. This is h, and since this controls roughness, we probably don't need this anymore, and we don't need condition, right? We don't need that condition. And here we just want to pass h, right? So first we need to calculate the new delta. So the new delta is going to be 2 to the power of negative h. So there is a function in math.h that already does power, right? Pow, yeah, pow f. Cool. And here I'm assuming this, we can do this, right, to the power of negative h. I'm assuming this is going to work. So now we can just say delta, and h is going to be constant, it's not going to change, I think. Yeah, cool. And this is also constant, we don't modify the segment. Okay, let me see what this generates. Oh, because we have, yeah, let me see, so we have start, end, delta, let me say max displacement, and usually, actually, the author also recommends the initial maximum displacement to be something like the width, or half the width, or something like that, isn't it? But I also, yeah, since I'm going to have multiple planets, I probably want this to be configurable, right? So, okay. And here I want to pass roughness. Let me say 0.5 for now. Let me say 0.5. What kind of terrain is this going to give me? Not very rough terrain. Right, not that rough terrain. I don't know what kind of delta this is generating. Let me say like 0.9. What does this do? Okay, not very pleasing, to be honest. Say 0.1. What does this do? I don't really like it, to be honest. I don't really like it. Let me printf the delta this is giving me. So, oh, because, interesting. Oh, but the age is a float. Yeah, so let me see. Just give me a bunch of zeros. Okay, let me go back to 0.5. Yeah, it's really not good. So bad, right? And why is it? So let me print the result of this. Oh, but this age. So this is, what is this? Oh, this is a factor, right? So this, oh yeah, I'm stupid. This is it times equals, not equals. Yeah, that's why it was not working. So if I do delta like that, oh my god, so many windows. Okay, this should give me, okay. This is much better. Okay, so this is very rough, and I don't want it to be that rough. So if I increment that, okay, it's something, right? I don't know if I like this better than the simple divide by 2. Well, but this is more configurable, right? We can use different functions for the factor. It's not bad, like, yeah, it's not that bad. What happens if I do like 0.1? This is going to be very rough, right? Yeah, this is like unplayable. What about this one? Yeah, probably like values below 0.6 are like unplayable, I would say. Yeah, 0.6 is already good. So this is a very mountainous terrain. I like it. I kind of like it. So yeah, I kind of like it, to be honest. With this we can generate some very nice terrain. Okay. So I still don't know about this well-dependent interpolator. Well, it kind of makes sense, right? If we don't use like a simple linear interpolation, we may have some better results. Who knows? Who knows? I don't really know, to be yeah, we can keep it like that. But this is basically our square step, right? So this is our square step, what Wikipedia calls the square step. and this is my diamond step, right? So all of these is my diamond step. And basically this is a lot simpler and probably faster than my initial implementation with that for loop, because what I understood is that since we are recursing through all of the points, I don't need to like interpolate all the points in the segment every single time, because all of those points are going to be the midpoint at some point of some segment. So I can just interpolate it at that specific recursion step, right? So what I'm basically trying to say that we are going to split this until the unit, right? So we're going to split this into segments until the size of a segment is 1, right? At this point we are not going to split it any further. And what I'm saying is that since we are splitting it until the segment reaches the unit, right? The unit value, every single point of this line is going to be the midpoint of some segment, right? So it's going to be the midpoint of some recursion step. And since it's going to be the midpoint of some recursion step, then we can simply just interpolate it at that recursion step. We don't need to interpolate it all the time, right? Otherwise it's wasted calculations. That's why I don't need for loops here, right? We can just do the square step on the single midpoint and no other point, right? Needs the square step. And same thing for the diamond step. So we just get the diamond step, we just increment it by a random value, and that's it. And we just do the diamond step, this specific calculation, if the delta is greater than 0. If the delta is not 0, then yeah, that is not going to be used. Okay, so what happens if I do 1? Actually, that's an interesting thing that I want to test it. It generates, yeah, it kind of generates me good terrain. So I can actually have like flat lines and stuff like this, right? So I just can manipulate this singular value, and I can have kinds of flat lines. So if I want a very flat, yeah, 1.2, still not enough, like 1.3. What do I get? Yeah, it's more or less. So if you compare like the 1.3 of roughness to 0.6, you can see like the big difference. You see like a very mountainous terrain versus like a more flat terrain. It looks good. So I can basically manipulate those two values, the maximum displacement and the roughness, to already have like a plethora of biomes and stuff like that. I think that for surface level generation, this generates very interesting terrain, to be honest. And I don't think I'm going to need any special algorithm besides this one for the surface. For caves and other kinds of structures, I'm probably going to think about other stuff. But we can call it this midpoint displacement. Alright, just to be sure of what we're doing. And yeah, and since we are interpolating every single point as the midpoint, we actually can do something interesting, right? We can actually do something like this. So we get height 0 and we set it to planet sea level, and then we get height z and we set it to planet sea level, and then if we run it still generates the correct terrain, right? And here we can actually initialize this with anything we want, right? We can actually do something like this, right? And let me say this is my delta, right? So this is minus delta delta. So we can initialize this with whatever we wish, and here I can pass delta. Well, and since I'm passing delta there, I can actually do something like this. Why not, right? Why not? Before, right? And well, okay, I want a comment. I actually want this. Right? This is my diamond step. So if I do this, my terrain. Oh, this broke it. Oh god. Yeah, I don't want to fix it. No. Okay. Okay. Let me just backstep to the point where it worked. So is this at breaks it, or is the other thing? No. Okay. Let me just do that. So I'll debug this later. Okay, but this is working. This is working. This is generating good terrains. Good terrains. Okay, I can already imagine like a player like digging and stuff like that and having an hard time navigating this terrain. I think this is going to generate some good gameplay. Cool. Okay, I think that's everything for today. I'm already programming for a very long time. I don't know how many minutes, like more than 1 hour probably. Tomorrow, what are we going to do tomorrow? I think I'm going to start working on the server. I think the server is important because the server is going to be the owner of the map, and I think that I want the server to generate the map, and the client is just going to receive the data through the network, and is not going to really own anything on that regard. So yeah, I think the server is important, and we need to start working on it. So yeah, tomorrow we'll be starting with the server, and until then, thank you for watching.